to another episode of the Jarring Science Club. We're so glad you're here, and we have some exciting experiments lined up for this month. It's dreary outside, it's winter, you're stuck indoors, so what are you gonna do? What better thing than to bring nice colorful science into your house in this dreary February? So, let's get to it. Today's experiment is changing the colors of light that you can see. We will be changing colors using the science of light refraction. We will be changing colors using the science of light refraction. Here's what you'll need. A clear glass bowl, a tall jar, liquid food coloring in yellow, blue, and red. Let's get started. The first thing you're gonna do is create your colored water solutions. And there are 3 secondary colors that you can make by mixing the 3 primary colors. If you mix yellow and red, you get orange. If you mix yellow and blue, you get green. And if you mix blue and red, you get purple. So you're going to need to create solutions of each of these colors. You will need red, blue, and yellow colors for your bowl, and then red, blue, and yellow colors for your jar. So I have 6 containers of water. First, place your jar inside the bowl. That way you know how much water to put into your bowl. If you don't do it this way, you could end up spilling. Take out your jar, pour your water into one of your other containers. Put your bowl containers on one side and your jar containers on the other. Now your jar you want to fill up to right about here, so some of the jar is above the water and some is below. Now we'll dye each of our colors. We need a red bowl. You don't want to add too many drops of water because if you put too much food coloring in, you won't be able to see through the color, and so your color mixing will be muddled. So I do like 3 or 4 drops per container. Now we'll mix up our colors. Now watch the magic happen. First we're going to put red in our bowl. Now we're going to put blue in our jar. Now you'll see the 3 different colors. You've got the red that you can see in the bowl, the blue that you can see in the top of the jar, but if you look through both containers, it appears purple. This is due to light refraction. Keeping the red in the bowl, add the yellow to the jar. This one's not really visible on the camera, but it's quite intense when you're looking at it with just your eyes. This whole middle section here is bright orange. Now we're gonna make my favorite, which is green. Isn't that so cool? I just love how it instantly changes color. Now let's see if orange works better when the jar is red. Orange is a tricky one. My camera doesn't like to pick it up, but when you look through the jar, you can see the orange clearly in person. When you do your experiment, let me know if you were able to see your orange. And now for the last one, instant green. That's it for today's experiment. See you next time. Here's the science. Today we found that by putting different colored liquids inside of a bowl of liquid, you can make different colors. The way that this works is that your eyes translate light into color. Color is not actually part of objects. You can't look at something and say, that thing is blue. That's not how the light spectrum works. Color works with how the light is absorbed on the surface of that object. The surface of objects reflects certain colors and absorbs certain other colors. Lights travel along wavelengths, and depending on which light waves the object absorbs or reflects, that changes the color that you see. The 3 primary colors of blue, red, and yellow are present in every color that we see. By varying these mixtures of colors, we can create just about any color that exists. The light we can see is measured in a spectrum. The spectrum of light energy that we can see has wavelengths between 380 nanometers and 780 nanometers. This makes up the visible light spectrum, the colors that we see. Different animals can actually see different wavelengths of light than humans. That's why dogs can't see as much color as humans, and why some birds can actually see more colors than what we can. The reason that the color of the liquid appears to change whenever you put the 2 colors together in liquid is the way that the light waves change whenever the 2 colors are in front of each other. Doing this, you can make the 3 secondary colors of orange, purple, and green. You can also experiment with either adding additional layers to your liquids to make even more colors of dimension, or varying the amounts of the 3 main primary colors that you put in to see if you can create other colors. You can also shine a flashlight at several different jars of color all lined up in a row and see if you can change what colors that's visible doing that. That's it for today. See you next time.